This video should be watched after watching SolidWorks training video number 4, and this talks about our assignment number 3. After watching SolidWorks training video number 4, I'd like you to work on adding the drive wheels to your chassis. I sent a quick email about this on Thursday. However, after that, Michael found a hurdle or two that must be overcome on this build, and I've not yet provided you with the training to handle that situation, so more on that in a bit. Right now, you should have this chassis with the 4 Omni wheels already built. And what we're going to be doing is to be adding 2 powered wheels, one on either side in the middle of this chassis. The basic description and instructions for this build can be found on this video provided by Servo City, and you will find the link in the description. One big difference between our build and the video provided is we want those drive wheels in the center of our chassis. So you can see here in this video he has put the motor and is going to be mounting these drive wheels at the far back end of the chassis. And if you look at this completed build, you will see the drive wheels are in the center of the chassis. Remember, those center drive wheels provided us with a nice 0-point turn capability. So make sure you mount the drive wheels in the center location. So the first problem you're going to have with this build comes when you are trying to mount the motor and the motor mount together. When you're trying to do the mates to accomplish that, you're going to run into some problems. Let me demonstrate what can happen. So the first mate I want to perform is to make the face of the motor mated with the backside of my motor mount. So I will mate those two together, and that is coming out as a coincident mate, so perfect. Now I want to move this motor mount around so that it will be close to the final position. So if I rotate it around, I can see that this position here gets these holes very close to my tapped mounting holes on my motor itself, and that's close to the position that I want it to be in. Now I will start doing my concentric mates on these screw holes, and start with the top. And I get a nice concentric mate there. Now I go down to the second hole, select on the face, the cylindrical face inside the hole on my mount. Again, go for these threads inside my motor mount. Notice when I select them, it is defaulting to a parallel mate. Since that's not what I want, I come on over and I change it to concentric mate. Then I say OK, and I'm getting this warning. The selected mate could not successfully be created. Well, I'm going to cancel then. Let's try again, and what if I just leave it at the parallel then? Okay, I'll leave it at a parallel mate. Well, what has happened at this point is I've got these mates in place, but they're not holding my face plate or my mounting, my motor mount to my motor. So that's just not giving me what I want. What is going on is that the holes, the distance between the holes on my mount and the distance between the holes on my motor itself are different. They're not different by much. I believe it's like 33 millimeters on one and 33.003 millimeters on the other. But even that itty bitty difference is enough that SolidWorks is saying, I cannot resolve this. I cannot put both of these concentric mates in place because the holes are just different. The distances between the holes are different. So how are we going to resolve this? So you may run into the situation on occasion, and the solution I'm going to show you may not be the proper way to handle every situation like this that you run into. But I do know in this case, for this specific scenario, this method will be the best way to handle it. So the first thing I want to do is to create my coincident mate between these two parts. Now I'm going to set up a concentric mate between the center hole on my mount and one of these center items on my motor. And when I say center items, something that is going to put this motor shaft in the center of my mount. So why don't I just take the hole on my mount and do a concentric mate on this face of my motor. Now my motor mount is directly centered on the shaft of my motor. And that is ideally, that's what I'm after long term anyway. Now at this point, it's a matter of getting those holes lined up, at least getting them lined up as close as possible. So I will take my motor mount and I will rotate it around until I see the holes lining up, and there they are. Now that the holes are lined up, I'm going to do what's called a lock mate. When I select a lock mate, it's like I'm telling SolidWorks to take these two parts and lock them in position, lock them like they're glued in position. So notice when I select a face on my motor mount, it is no longer telling me or pointing to a specific feature on the motor mount. It's actually selecting the entire motor mount itself for this mate type. So I clicked on lock first, then I clicked on motor mount, now I click on the motor, and now when I say OK, I've only got the the three mates in place. I could theoretically delete these other two mates. They simply helped me get my two pieces into a good position, and the lock mate could now carry me through now that the lock mate is in place. I will leave the other two mates in place because being able to identify those relationships down the road as I'm doing other things with this subassembly will help me identify what parts are lined up with other parts in the assembly. Again, I should stress, this type of mate should only be used in rare circumstances. Please check with me if you believe you should be using it on a different occasion, and we can look into that together. Now, there are a few other notes that I want you to be aware of with these parts. One is that the screws, the physical screws that you use to mount this motor mount to the motors, and if we go to the website, we will see these screws are provided. They are 3mm by 6mm motor mounting screws. Those screws did not come from SolidWorks in the step file. So we do not have these screws modeled in SolidWorks. So in this occasion, you will be leaving those screws off. Again, rare circumstance. I do not want you to get into the habit of omitting screws in your SolidWorks builds. Secondly, these holes here, these 4 holes on the mount, these are the 4 holes that you'll actually be using to mount this motor mount to the channel. Again, if we look at the website itself, we can see these holes are threaded. These are tapped holes. It is a rare circumstance that Servo City provided step files, or the CAD files that they provide for us are not accurate, that they don't show the tapped holes when they are tapped holes. But you need to know that these are supposed to be tapped holes. So when you're mounting the motor mount to your chassis, you do not need nuts. These holes, these 4 holes here, are tapped. And the last thing I want to mention is to make sure that you are using sub-assemblies. So again, here's what your final build will look like. At the minimum, you should have at least a sub-assembly that represents the motor with the mount and any spacers and screws and the wheels, etc., that you would need. If you believe there is an opportunity to create additional sub-assemblies inside here for whatever reason, certainly take advantage of that, and there might be a reason to reuse sub-assemblies that you create for this in future builds. All right, guys, have fun.